So let's turn our attention to your DHCP. Again, DHCP stands for Dual Hydrogen Control Panel. And we'll review what it does. It has two main functions. The first is to measure and monitor the generator purity. And that's a safety feature and required on all hydrogen-cooled generators. The DHCP monitors hydrogen in 4 locations, 3 of them during normal operation. Those would be from the turbine end seal drain enlargement tank, from the collector end seal drain enlargement tank, and from the generator case. The DHCP can also sample gas from a purge sample port located on the manifold, and this is used when generator purge procedure is taking place to monitor the conditions of the gas as you're transitioning from hydrogen to air. The DHCP also plays a role in the efficiency of the generator by maintaining generator purity through the control of the scavenging flow rates. Hydrogen is vented from both the turbine end and collector end seal drain enlargement tanks through control valves located on the DHCP panel, and this maintains the generator purity. It's important to note that the DHCP is specifically designed for use on generators with scavenging seal oil systems, in particular, the larger GE Frame 7 and Frame 9 gensets. We mentioned the role that the DHCP plays in efficiency on the prior slide. On the screen in front of you is an example of a study that was conducted some years ago. The study was conducted on a coal-fired generating plant. So the exact figures on the screen may not apply to your generator today. But what's important to note here is the impact that low purity has on the losses in the form of kilowatts of energy that are converted to heat, and through the losses associated with rotating that rotor through a denser gas, and that plays a role in cost. You're losing that fuel, instead of turned into electricity, is now lost in frictional losses within the generator. So maintaining the generator purity at the OEM prescribed levels ensures the optimum generator efficiency and maximum dollar output for your unit to the fleet. Excuse me. So specifically, how does it work? So the DHCP has 2 thermal conductivity analyzer cells that continuously monitor the turbine end and collector end seal drain enlargement tank purity levels. These analyzer cells are located in the large flame-proof enclosure located in the lower left hand of the unit shown on the screen there. The scavenging flow rates are set during commissioning, and they continuously vent 1,000 cc's a minute of hydrogen gas per side, so out of the turbine end and out of the collector end, to vent. And the total flow meter on the screen indicates that flow rate. In the event that the collector end or turbine end purity levels drop below a warning level, a solenoid will activate in the DHCP to increase the scavenging flow rate to a total of 2,000 cc's per minute of hydrogen per the affected side. Once the purity level goes above that warning level, the solenoid will close and the normal scavenging flow rate of 1,000 cc's per minute will be returned. Once per hour on units that are directly coupled to the control system will send a signal and switch the turbine end and collector end sampling to the case. And it'll sample from the case for 10 minutes per hour. And what that does, it allows the control system to compare the case purity sample to the seal drain enlargement tank purity. The case sample should run higher than both of the ends. And when you look at the end, the turbine end or collector end value, if it's drifting further away from the case, it's an indication that the seal on that end of the generator could be deteriorating and be in need of maintenance. So some other functions that the DHCP performs, it's also measuring and monitoring the generator fan differential pressure. There's a gauge and a 4 to 20 milliamp pressure transmitter. That signal is sent back to the control system as well. In the event that the purity analyzer can't be trusted or there's a concern, the differential pressure can be used to map to a purity level. It's one of the original methods of monitoring purity in these hydrogen-cooled generators. The DHCP has large desiccant-style purifier cartridges, one on the turbine-end sample line, one on the case sample line, and one on the collector-end sample line. This ensures to protect the analyzers from oil contamination. We're sampling from the seal drain enlargement tanks. So that's an oil source. The opportunity exists for some oil vapors to be brought in or droplets, and that could cause an issue with the reading of the analyzer and needs to be attended to, and the filters will protect the analyzer from that. In the event that you lose control from the DCS or it's not available in some of the installations, the DHCP can be manually controlled with switches that are located on the front of the flame-proof enclosure. These switches control whether you're sampling from the turbine end, collector end, or the case, and can be used to increase the scavenging mode, as well as selecting calibration and purge mode. So one of the first pieces of information it's critical to have for your DHCP is the model and serial number. This information is located on the system nameplate. The system nameplate is located in the lower right-hand corner of the large flame-proof enclosure in the bottom of the cabinet. The model and serial number are located here, as well as the manufacturing date and some other information specific to that DHCP. And when you call into E1 for support on your unit, providing this information will ensure that you get efficient problem resolution and that we can provide accurate spare part support to you and your staff. So as far as operating your DHCP, one of the first things you need to understand is where to go for critical information. And that's located on the DHCP displays. You'll notice that the DHCP has two displays. Again, that dual term refers to the fact that we have two analyzers. Each analyzer has a dedicated set of electronics and a dedicated display. On the DHCP display is a multifunction LCD, as indicated on the lower portion of the screen here. That multifunction LCD allows you to gain access to critical information, control parameters, fault codes, settings, and the ability to control the unit through different modes of operation. Referring to your DHCP software manual to provide specific details regarding the menu navigation. In the video that you'll be sent a link to after today's webinar, we walk you through the basic modes of operation of the DHCP multifunction display. So let's talk about maintaining your DHCP. The first thing we want to do is keep an eye on it. So on your daily checklists as you walk through your plant, the first thing we want to do is we want to look at the LED status on each of those display panels. We want to confirm that the AC power LED is lit, confirm that there is no trouble LED lit, and confirm that the normal H2 and air LED is active. We want to check our purity readings. When you're sampling from the ends, GE recommends that purity level will be between 94 and 96%. If while you're monitoring the unit, it's in its case sampling mode, you'll notice that the purity should be up around 98%, as high as 99% on very tight generators. One of the things that we get when people call in is they've got a concern that their their generator's not operating at 99% purity. Each generator manufacturer has a different expected purity reading. So potentially if you're coming from a plant that is operating a different manufacturer's generator that may operate at 99 or 99.5% purity, if you're operating a unit that has a DHCP, these are the values that are anticipated and expected on your unit. Continuing with your daily checklist, you want to confirm the flow settings. So at the top of the unit between the two display panels are 3 flow meters. The 2 outer flow meters represent the analyzer flow on the left and the right to the analyzers associated with them accordingly. The analyzer flow should be 500 cc's per minute. This can be adjusted by adjusting the ball valve directly right there on the flow meter. The total flow meter is the one in the center, and that should be between 3,000 and 5,000 cc's per minute. And that'll vary depending on whether or not you're in increased scavenging mode. So your base flow rate is 3,000. That's both analyzers at 500 for 1,000, and both ends at 1,000. So that's your total of 3,000. If you're both ends at increased scavenging mode, then they're both at 2,000, and that 1,000 for the total flow of the analyzers brings you up to 5,000. So the analyzer flow can be adjusted during normal operation. The increased scavenging flow and the scavenging flow rates are adjusted during an commissioning or during an outage period. The next thing you want to look at is your valve lineup, and just below the analyzers is a series of manual valves, and we want to confirm that the upper row, the ones identified in the red circles, HVs 2971, 72, 73, 74, are all rockered to the on position, and that 2978, and that's the case sample to the lower right, is also in the on position. Excuse me. And lastly, we want to look at our solenoid valve positions, and those switches on the face of the flame-proof enclosure should be all rockered to the full counterclockwise position. In addition to your daily checks, a couple things to add on your weekly checklist, and that's to check your moisture indicators. The moisture indicators are the spherical brass elements located above the purifier cartridges. When they are clean and brand new, they're a blue color. When they are white or yellow, that's an indication that there's been breakthrough in your purifier cartridge. In the event that the indicator is yellow or white, you need to change the purifier cartridge and the moisture indicator. If you're not changing them on a weekly basis, well, you shouldn't be changing them on a weekly basis, but if you don't change them on your weekly check, you should perform a blowdown. There's a valve located beneath each of the purifier cartridges with a cap on the outlet of that valve. You remove the cap and you rocker the valve to the on position, and that would release any liquid oil or moisture that's collected in the pipework. This should only be performed once checking and following safe plant protocol for the presence of hydrogen gas. So in addition to your daily and weekly, we've got a biannual checklist that should be performed. The first is through the multifunction display, checking your power log. There's several circuit boards within the DHCP that rely on different power sources. The power log records the value of those power outputs, and that is accessed through the log menu. The next thing to do is to view your calibration parameters and your cell voltage. Those are viewed through the view menu. One of the best practices would be to keep a logbook to have a history of this information. and then be able to refer back to it on the every 6-month check. And to have it available when you call into E1 if there were a problem. You can run system diagnostics. This is accessed from the test menu. The diagnostics will perform a contact test, which would cycle all the contacts on the I/O boards. A keypad test can be conducted to ensure that all the functions of the keypad are working properly. An output test can be performed, which will vary the 4 to 20 milliamp signal, and you can validate that the control room settings are active and reading those properly. The power test will check those supply voltages we mentioned that the power log is recording the values of. And the relay test will test the relay functionality of the I/O board. When conducting these tests, it's important to note that there could be an impact on your runback system. So it may be necessary to force points in the control room before you run the system diagnostics test. And then the last thing we recommend every 6 months is to perform a calibration of the analyzer cells. This procedure is accessed via the setup menu and is also referenced in your manual. And again, because at this point you're taking the cell offline to perform calibration, it may be necessary to force points to prevent an issue with a runback because the analog signal for the purity will be varying greatly during the calibration. And again, the procedures we're referring to here will be also reviewed during the video that we'll be sending out after the end of the webinar. So I threw up a few maintenance-focused, frequently asked questions we get on the hotline. The first one is, does oil contamination damage the purity cell? And the answer is no. The oil affects the cell accuracy, but doesn't affect the longevity or performance of it, other than affecting the accuracy because of the sheen of oil that forms on the thermistor within the design. Our decontamination procedure will restore the cell back to factory performance. Do I need to change the purifier cartridges when I change the moisture indicators? And the answer is absolutely yes. The moisture indicator, again, is just an indication that you have a breakthrough of the cartridges and that they're saturated. So once you have the indication on the moisture indicator, you need to change both that moisture indicator and the associated filter. And can I change the moisture indicators and purifier cartridges while the DHCP is in operation? The answer is yes. The circuit associated with the moisture indicator and purifier cartridge can be isolated. It's important at this point to follow plant safety protocols for work in a hydrogen area. As I mentioned earlier, it may be necessary to force points as well because you'll be isolating the flow of gas through that circuit during the period of time you're performing the maintenance procedure. So in review, we discussed hydrogen properties and the hazards when associated with working with hydrogen gas. We reviewed what a hazardous area was and the best practices for working in a hazardous area. We discussed the function of your DHCP and how it works, and we walked through the maintenance procedures associated with your DHCP. So at this time, I'll take any questions that you may have. And as always, it's all about safety, risk mitigation, and reliability. Thank you.
Gus, thank you so much for that excellent presentation. So we'll start right in on our Q&A session. We seem to have plenty of time for that, so don't be shy. So Gus, here we go. Okay, we have a couple questions from actually the same individual. What is the standard voltage we should get during calibration?
Okay, good question. And that varies based on the gas that's being calibrated. So it's probably best, I don't want to repeat incorrectly the information that's going to be provided by our great lead service technician. Chad will be reviewing that during the video, and he'll walk through what the standard ranges are expected on each of those voltages as you apply those gases. During normal operation, the sample voltage should be between 3.5 and 4.0.
Okay, and then their follow-up question is where to recondition the thermo-conductivity analyzer. Our location is in the Middle East.
So there is no reconditioning. What we can do, it depends on the situation of that particular unit. We have agents located, channel partners in the Middle East. So we can assess the situation on your particular unit. We can perform a cleaning procedure on your machine. We have a service technician that's semi-permanently stationed there, and that could provide that service. From a reconditioning standpoint, if the cell has failed, we would recommend a replacement with a new cell. So it'll be dependent upon the specific condition of your unit. I think the best thing to do would be to call into our tech hotline, provide the information associated with your unit, and we can take it from there. Okay, and I think you kind of answered this as well, but the third question from this individual is there a cartridge available for the thermoconductivity cell? So the thermoconductivity cell itself is a replaceable element. That would be what we would offer as a replacement if that has truly failed or reached its end of life on your specific DHCP. Okay, thank you. And what is the full form of DHCP? Full form. I don't know if they're wondering, maybe they came in late on the... Oh, maybe, okay, so yeah. Dual, yep, there we go. Thank you. So from an acronym standpoint, DHCP stands for Dual Hydrogen Control Panel. And again, that's an acronym for GE's specific reference to it. If you have an older GE machine, they might only refer to it as a hydrogen control panel. Okay. What is this is a new question. What is the PC percentage and how would this affect the measurement? This is somebody who's been playing with their machines. So PC stands for purity compensation. That's a factor we use in the definition of that particular purity cell to ensure that we maintain full accuracy of the cell across the range of performance. So purity compensation factor is fixed at the factory when we manufacture that cell, and that is an element that is put into the software when you replace the cell with a new cell. The purity compensation factor for the new cell would have to be entered into the software so that the mapping logic for the purity value is carried over for that specific cell. I hope that answered the question. Okay, very good. This question comes from Ken. CO2 is used to degas generator and purge out H2. Can the DHCP also monitor the degas process in terms of H2 being exchanged by CO2? And do DHCPs have temperature compensation for purity accuracy? So a couple different questions there. Oh, very good questions. So the first question about CO2 measurement, yes, that is the fourth measurement location that the DHCP has. And it's typically located on the manifold, the gas manifold area. A sample line is run from the gas manifold to the DHCP. And then there's a manual valve and a solenoid valve that's activated to pull the sample from that location. And then you set the analyzer for the purge mode for hydrogen and CO2, and then CO2 and air for the final step. The second question was in regard to temperature compensation for accuracy. Yes. So E1's approach to that is that we have a cell block heater that's part of the thermal conductivity cell. What we do is we elevate the temperature of the gas above the ambient temperature, and that enables us to eliminate the temperature effect, the ambient temperature effect on the gas sample, to ensure an accurate response across all ambient temperatures.
Okay, and our next question for you, Gus, is how much can the purity reading accuracy be affected by oil and moisture present on the machine tubing?
So we don't have we don't have a study on the exact percentage impact. We know it does have an impact, and it'll vary based on the level of contamination. So unfortunately, we don't have a study that says, if you've got, 1 micrometer of oil on the bead versus 2 micrometers of oil. We just know that it does have an impact. I think one of the larger issues we run into is the inability to properly control the scavenging flow rate because of the oil contamination. And that becomes an even larger issue when you're trying to maintain your purity and you're unable to get the right flows or know that you've got the right flows on your machine to maintain that purity. So the combination of the inaccuracy of the purity reading and then inability to control the flows where you want to become a concern.
Thank you, Gus. Good afternoon. Is there any shelf life for hydrogen stored in cylinders?
That is a question I don't have the answer to, but I would check with wherever you're purchasing your cylinders, the manufacturer of that hydrogen gas should be able to provide that answer for you.
And some more questions coming in. Please ask away. How can we link the dew point gauge readings with H2 accuracy of display?
So dew point has a very small effect on purity level. It would take a very, 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 very high dew point to even begin to approach an effect on the purity reading of the gas. I don't have the exact values in front of me. There was a study conducted to show at what dew point you even begin to affect purity. I can take that question down, Rach. We can do a little research and try to get the answer back to that gentleman or lady,
Sure.
Whoever provided the question. Yeah.
Very good. And just to revert to the previous question, the attendee provided a little bit of clarification, so this might help. So is there any shelf life for hydrogen stored in cylinders? And he means from the hydrogen generator. So does that help at all, or?
Yes, I can imagine. Yeah. So bottled gases have a dew point of minus 70 degrees centigrade. So the only thing I can think of that would affect the gas would be a contaminant, and you're getting 4 or 5 nines worth of gas. So I don't believe that there's a shelf life concern, whether it's from bottled gas or from a local H2 generator to a bulk storage tank. But again, this is best passed along to whomever your supplier of hydrogen is, just to confirm that.
Okay, very good. What is the calibration frequency of DHCP, and how frequently is the replacement of moisture indicator and filter cartridge required?
So we recommend a biannual calibration every 6 months, and that's to maintain the stated accuracies in our catalog. We can extend that to a year. Many plants wait and do it on an annual basis. And that comes to your second question, how frequently do you replace your moisture indicators? That's going to depend on the amount of oil carryover you're getting in your sample lines, which is a condition based on the design of the seal drain enlargement tank. GE has gone through several iterations of that over the years. There's some machines that are more prevalent to having oil carryover in the sample line and in the scavenging lines, and there's other machines that have less carryover. If you have a machine that's got a large carryover, E1 does offer an additional filtration kit that can be installed between the sample point and the DHCP to help offload some of the removal of that oil contamination.
Okay, and how much is considered a normal consumption of hydrogen? In our plant, we have a consumption of 4 cylinders per day for 1 generator.
I would have to take that one offline and get back to them, and that'll we'd have to look at the flow rates and do a conversion back to cylinders, which I don't have that right in front of me today. I apologize.
Okay, but we'll certainly follow up with this attendee. And can the DHCP be located outside?
Yes, we have 2 models. Throughout the presentation, the model that I represented was a model that is typically located inside the collector cabinet. And that's because it has a better visual ability to see all the components. We have another design that's located or housed in a NEMA 3R cabinet. All the same components, and it's just housed in a cabinet for outdoor installation, and it has a thermostatically controlled heater for the cabinet to maintain the temperature inside the cabinet. So please reach out to E1, contact us, and we can help you out with that.
Okay, very good. Now here's 2 questions on the thermocell. So is the old model of the thermoconductivity cell becoming obsolete, and how long is the life of the thermocell?
So from an obsolescence standpoint, our current purity cell replaces all purity cells that we've ever manufactured. So we've all the way back to the very first one. The part number may be different, but it's form, fit, function identical. The second question is the life. We would expect the life of the purity cell to be between 5 and 10 years as a normal expected life. We've got some machines that have been operating 10, 15 years with the same cells, working just fine.
Okay, and here's a bit of a question saying, hello, Gus, thank you for your presentation. According to your presentation, are the purity readings of ends approximately 94 to 96% and of case approximately 98%, right? Not 99.9%?
That's correct.
Okay, so the follow-up question would be, why not 99.9% in spite of being used calibrations? Gases are 99.9%.
Yeah, that's correct. And that comes into play with the design of the scavenging seal oil design, and the tightness of the seals on these generators result in more air being diffused through the oil into the hydrogen, and you get a certain purity as a result of that. So when you go through the GEK, the GE manual for their generators, those values I presented earlier are right off of their literature. 99.9 is very suspicious to me for any generator, because that's more indicative of no leakage, which doesn't exist, or potentially a purity analyzer that needs to be recalibrated, which is more likely the case.
There's a good tip there. Can the DHCP be connected remotely by Bluetooth in order to get its actual measured values or calibration results?
We have been unable to find a Bluetooth that will operate that's EX certified or can operate with the EMI interference of the generator. So those are 2 design challenges when it comes to Bluetooth. We do offer RS-232 and Modbus communication as an add-on feature, but again, that's over wires. We don't have any wireless transmission available today.
And can I read the hydrogen purity in the control room?
Yes, you can. So there's analog outputs for both purity analyzers that can be brought into the control room with a 4 to 20 milliamp signal. And again, it depends on how much cabling has already been brought down to the unit. You might have to bring extra cabling in to get that signal brought back to the control room.
Okay. Is the thermo cell directly replaceable? Any parameter changes required when we replace the new thermoconductivity cell?
Yeah, that is contingent upon the software version you're running on your machine. So when you call in for your replacement cell, we may ask you to go in and get the software version of your machine to ensure compatibility first, that we have two styles of cells. And also to that exact question, if you need to type in that purity compensation value, which is available only on the newer software versions. And when I say newer, 10 years. So in this industry, new is 10 years old. So,
so clients frequently perform a calibration with just one gas, which is H2. How does this affect the measurement?
that's a great question. I'm going to assume one of my colleagues threw it at me because I forgot to mention that. Yes, calibration must be done with all three gases. And that's because the design of the cells looking at all three gases, and we need to make sure that any drifting that's associated is captured for each of the phases, so each of the gases. So thank you for bringing that question to the forward.
JL asked that question. So thanks, JL. Let's see. Can the DHCP be used on generators with vacuum type seal oil systems?
So that's not the design of the DHCP because of all of the additional features on the DHCP are associated with scavenging style generator. If you have a vacuum seal oil system, E1 offers many other options for purity monitoring that are more that are focused on the vacuum seal oil design. So if your goal is to upgrade your purity analyzer system on your vacuum seal oil system, please reach out to your local agent or call into the tech support hotline. We can work up a solution for your specific situation.
And I think this is maybe someone who came in late to the game, but what determines when the DHCP will increase the scavenging rate to increase the hydrogen purity?
Yeah, it's a good question and worth repeating. So the analyzer has warning settings, and the control room typically mimics that warning setting for a low purity warning, and that warning is what it initiates the increased scavenging mode. Now that can be programmed differently in the control room, but typically it matches. So if our low purity alarm or warning is at 95, the increased scavenging mode would kick in at 95%. But again, that can vary from plant to plant. The gentleman earlier who was asking about hydrogen consumption, sometimes plants that are running at a 95% point when they go into increased scavenging mode are finding that they're consuming just too much hydrogen gas. So if they adjust that point in the control room to 94 or 93%, obviously with the consultation with their GETA, they'll find that they reduce their hydrogen consumption while maintaining still safe purity levels on the ends based on the age and condition of the seals on that generator.
Okay, well, Gus, you have answered all of the questions that come in. So I think it looks like, as a matter of fact, we're just about out of time. So on behalf of all of us here at E1, we thank you for joining today's session and look forward to seeing you soon. There'll be another webinar series coming out. The next one will be in August. You'll receive information on that. And that will be taking a look at our generator condition monitors, the explosion-proof design. And on that note, everyone be well, and thanks again for attending.